I am going to do a very important question from wave optics class 12, which is also one of the physics PYQs, and which is very important, which you need to take care of, which you need to this question is important and it has been asked several times in the examination, so you need to pay attention to here. So I'm going to give you that what are the basic thing which you need to know. I hope you are done with basic and I'm going to do this important question. So the question goes like that: a beam of light consisting of two wavelengths, that is 560 nanometer and 420 nanometer, okay, is used to obtain the interference fringes in a young double slit experiment. Okay, so there is a YDSC question. This is a question of YDSC, so I hope you are, all the YDSC concept was clear to you. Find the least distance from the central maximum. Even if it is not clear, then you don't need to worry. I'll tell you that what are the basic things which you require to solve this type of question. Where the bright fringes due to the both the wavelengths coincide. So this is very important. Where the bright fringes of the due to both the wavelengths coincide. So we have given here two things. So first of all, let me write it here. The first wavelength is given here 560 nanometer, and the second one is given here, that is 420 nanometer. Okay, we have given two wavelengths. Find the least distance from the central maxima where the bright fringes due to both the wavelength coincide. The distance between the two slits is 4 millimeter, and other thing is also given. What are these three? 4 millimeter and 1 millimeter. Okay, so what are these three given? The distance between the two slit, that is denoted by small t, that is given here 4 millimeter into 10 to the power minus 3 meter. I have written here, and the screen is at a distance of 1 meter. It means that the distance between slit and screen is, it means that capital D is given here 1 meter from the slit. So we are provided with all three values we have been provided with, and we are required to find the least distance from the central maxima. It means like that. Let me explain you. For example, let's suppose here we are, this is the screen, let's suppose, and this is okay, sorry, this is suppose a slit we have. Okay, this is what central white maxima, and from here we are required to find the distance. Why? So that the wavelength of both the two wavelengths we are given here, they coincide with each other. Okay, we are required to find this distance y. So look, here two value can come. Okay, lambda 1 lambda 2 is given here. So let me start it again here. So lambda 1 lambda 2 is given here. Okay, now we know the formula of the bright fringe, that is y. If I am required to find the nth bright from the central maxima, distance of nth bright from the central maxima, then what it would be? I hope you know n d lambda by d. That is the formula which you need to remember. If you don't know, please remember it. This is the formula. And if you want to find the nth dark, then it would be go like this: 2n minus 1 n d, sorry, this is wrong. Okay, d lambda by 2d. Okay, I hope if I am not wrong. Yes, okay, I am not wrong. Okay, so n lambda and 2 lambda is given there. Now we are required to find that this. Now as it is two wavelengths are given there, it means that we are required to find the value of n, so that we can find the distance, because value of n is the critical data. Except n, all things are given, that d is given, lambda is given, d is given, but only thing which is not given is the n. So we are required to find n here. Okay, so let us find n here. So as we have two wavelengths, so let's suppose corresponding to lambda 1, let's suppose this to be n1. Okay, and corresponding to lambda 2, this to be n2. Okay, so if I'll require y n1, okay, n1 bright, that would be equal like n1 d lambda by d, and y n2, that would go to n2 d lambda by d. Now according to question, okay, lambda 1 and lambda 2, according to question, they both are coinciding with each other. It means the distance this and the distance this would be equal, then only they can coincide with each other, isn't it? So I am equating both of them. So n1, okay, I hope everything is visible to you. Okay, so n1 d lambda 1 d is equal to n2 d lambda 2 d. Okay, and d is the common part which will get cancelled out. Okay, we are left with n1 upon n2 is equal to lambda 2 upon lambda 1. Okay, so n1 upon n2 is equal to lambda 2, and lambda 2 is given there. What is given there? Lambda 2 is 420 nanometer. So 420 nanometer, and this would be 560 nanometer. What I can say, 344. This implies n1 4n1 is equal to 3n2. We have reckoned this solution. And what are the value of n1 and n2 so that this equation is satisfied? Of course, you will tell me that n1 value, it might be possible that n1 would be 3 and n2 would be 4. Then only it can satisfy. 4 3 is 12. If I'll put n1 3 equal to here, then from here LHS 12 will come. And if I'll put n2 equal to 4, then here from 3 to 4 12 will come. So LHS is equal to RHS would be done. Okay, now moving ahead. So n1 equal to 3, n1 3. Now which value we want to, we can take this value as well, this value as, but corresponding to that wavelength should be but corresponding to that n1 value, that wavelength we are supposed to take. Okay, both value will come same, because they both are coinciding with each other. So let's suppose I have taken here n1. So let me write it here. Y n1 bright is equal to n1 d lambda 1 upon d. Sorry, this would be small d, no, this would be small d. So I am writing small d here. n1 would be, n1 is here is 3, d is here, d here we have we have given d is 1 meter. Okay, 1 into lambda 1 is 560 nanometer. Okay, 560 into 10 to the power minus 9 nanometer. I hope 1 nanometer is equal to 10 to the minus 9 meter. And d is given there. What is given? D is given there 4 millimeter. 4 into 10 to the power minus 3 meter. Let's solve this. 4 1 is 4, 4 4 is 60, 40, and this would be go like that. 140 into 3, 43 jar 42 into, after solving this 10 to the minus ये ऊपर जाएगा plus 3 minus plus 6 into 10 to the power minus 6, and plus 6 also given there, so it would be plus 5, sorry, minus 5. So I hope this is the answer. Let me check it here. Yes, this is the answer, and I hope you are done with the answer. So this is the answer. I hope everything is clear to you. If everything is not clear to you, this is the whole solution we have. Rewind the video and check it once again. I hope I have tried my best to let you understand. So if you have still have any doubt, then do let me know in the comment section. I'll try to sort it out. Thank you for having your time, and I hope everything is clear to you. Thank you so much.